Hello everyone. In today's session, we will discover the pivotal role of Terraform modules in enhancing reusability and optimizing infrastructure as code workflows. So these are the table of contents which we are going to learn today. So let's start. What is Terraform? It is an open source infrastructure as code software tool where you define and create resources using providers in the declarative configuration language, example JSON. So with Terraform, you can package and reuse the code in the form of modules. It supports a number of cloud infrastructure providers such as Amazon Web Service, Microsoft Azure, Google Cloud Provider, IBM Cloud, and etc. So what is Terraform module? So Terraform module is a set of configuration code files with structured folder architecture. So we can create this module to combine resources that are used for specific single operation, which reduces the lines of code needed to create related infrastructure components. So for example, if we build a project on VPC and if we need it after 10 days, so we can refer this by using Terraform module and we can use the source of the first created VPC to create another VPC project. Further, what is dry principle in Terraform modules? So dry principle says don't repeat yourself, which advocates for avoiding redundancy and duplication in code. So the goal is to minimize the repetition by encapsulating common functionality in a model and reusable way. So the dry principle specifically applies for the software development area, even in the infrastructure as code. So we are actually developing something with the help of code. And this is the reason why dry principle even applies here. So let's go ahead and understand about the dry principle. So we will just revise. In software engineering, basically dry stands for don't repeat yourself. It is basically a principle of software development which is aimed at reducing the number of repetitive patterns with the software code. So let us refer this diagram. So where there is one source and we used to give the value to the specific source and in all Terraform TF files. So we used to refer or we used to reference this specific source within the TF file. So this is what variables are all about. Now the dry approach is very similar. So let's assume that there are hundreds of projects. Then in 100 projects, we will having 100 resource block. So which might contain very identical value. And this is what a repetitive pattern means. So like in 100 projects, we are actually having the same repeated value. And this is one of the main things that we want to avoid in infrastructure as code based methodology, where generally TF file that we have been writing the specific resource block is something which is repeated across multiple projects. And the aim of dry principle is to reduce the repetitive patterns. Now same goes with elastic IP or same goes with the another resource. So if two projects have same resource, so that resource will be repeated with elastic IP or it be a load balancer related resource in Terraform. So what's basically do in a centralized structure that we have a source over here. So within the source, this is very similar to the variable part. Within the source, we reference the Terraform TF file, we reference to the source. And we basically give the value, we give the resource block to the source, and within the various TF files which are included in the project, we directly reference it into the source. So what happens here is that terraform.tf files, this will be like almost empty. It will not really have much code. So the code will be centralized into the source block, and this is what is called as Terraform module. So for example, earlier we built a two-tier architecture using Terraform in AWS. So as we can see, it contains 100 lines of code. So to avoid this, we can use Terraform modules. So it can be easy to refer the code from another resource and create the resource in AWS. So after understanding about dry principle in Terraform module, so let us understand what does a module do. A Terraform module always allows you to create logical abstraction on the top of some resource set. In other words, a module allows you to group resources together and reuse this group later, possibly many times. So let's assume we have a virtual server with some features hosted in the cloud. So what is a set of resources might it describe that server? For example, a virtual machine itself created from some image, an attached block of device of specified size for additional storage, a static public IP map to the server virtual network interface, and a set of firewall rules to be attached to this server. Other things like block device, additional network interface, and so on. Why use Terraform module? A Terraform module always allows you to create logical abstraction on the top of the resource set. In other words, a module allows you to group resources together and reuse this group later. So assuming if you have a EC2 server that is hosted on AWS. So what AWS is this EC2 server is using? EC2 instance itself, EBS volume for store application data, an elastic IP for public access, a security group for inbound and outbound traffic, a VPC, a subnet, and etc. So what are the components of the module? So a typical Terraform module consists of the following components. First is the main.tf. So this file contains the main configuration for the resources defined in the module. And the variable.tf define the input variable that user can customize when using the module. And the output.tf specify the output values that users can retrieve when the module is applied. And the readme.empty documentation detailing how to use the module, including variables, outputs, and any specific consideration. Types of Terraform module. So with Terraform, you are likely to come across one of the three main categories of the module. So first is the root module. So the primary entry point for Terraform configuration. It contains main configuration file typically orchestrating the deployment of multiple resources. Serves at the top level module in a Terraform project. Second is the child module. Subordinate modules encapsulated within the root module or other child module. It focuses on specific functionalities or resources contributing to the modular structure of the infrastructure code. It enhances code organization and maintainability within the broader project. And last is the published module. So external modules shared and published for broader use. Created by the community or organization to facilitate the reuse of well-designed infrastructure components. It access to various resources such as Terraform registry, offering built solutions for common infrastructure patterns. So the three main components of Terraform module is root module, child module, and published module. So the root module is where we type our main configuration, and the child module is where we refer the main configuration in the child module. And the published module, we can use the published module from the Terraform registry. We will see that further. So what are the benefits of using Terraform module? So first benefit, it gives benefit of reusability. The modules enable the creation of standardized reusable components that can be easily employed across different projects and environments. Abstraction. So they provide a high-level interface abstracting complex infrastructure details and making it simple for users to interact and understand. It maintains by encapsulating resources, configuration, modules, enhanced code organization. making it easier to manage and update specific components without affecting the entire infrastructure. Collaboration. It facilitates teamwork by allowing teams to share and contribute to a standardized infrastructure component. Input and output value. It supports customization through input variables and facilitates information retrieval via output value, adding flexibility and adaptability to the module. Granularity. So it promotes a balanced granularity, ensuring that modules encapsulate a specific functionality without becoming overly specialized or monolithic. Documentation enhances clarity and understanding through well-documented modules describing usage, variables, and consideration, making them more accessible to users. So, what are the potential drawbacks of Terraform modules? So, despite having many benefits of Terraform modules, there are some demerits to consider. First is complexity. Models can add complexity, especially when they are nested or highly parameterized. So this complexity can make models difficult to understand and maintain, particularly for larger teams and projects. Second is versioning. So versioning models can be a challenge. When a model is updated, you need to carefully manage the version used in your different environments to avoid unwanted changes. Flexibility versus standardization. While models promote standardization, they may limit flexibility. A highly abstracted model may not cater to all use cases and could require changes to meet specific needs, which can undermine the principle of reusability. What are the cloud providers which support the Terraform model? So Terraform hosts extensive support for various cloud providers, enabling users to manage infrastructure across multi-cloud and hybrid cloud environments. So as you can visit the Terraform registry and you can browse the provider, and this is the list of the provider used by the Terraform. So as you can see, there are many cloud providers. So the following cloud providers have official support for Terraform model. So mainly Amazon Web Services. So Terraform has robust support for AWS services and numerous models are available for provisioning resources such as EC2 instance, S3 bucket, and more. Second is Microsoft Azure. Azure users can leverage Terraform modules to provision and manage resources like virtual machines, storage accounts, accountants, and networking components. Google Cloud Platform. So Terraform modules facilitate the deployment of Google Cloud Platform resources, including compute instances, storage buckets, and networking configuration. Alibaba Cloud. So Terraform supports Alibaba Cloud, enabling users to define, deploy resources in the Alibaba Cloud environment using modular code. Oracle Cloud Infrastructure. OCI users can use Terraform modules to define and deploy infrastructure components such as compute instances, block storage, and networking resources. DigitalOcean. So Terraform includes a provider for DigitalOcean, allowing users to define and manage infrastructure resources on the DigitalOcean platform. VMware vSphere. Terraform provider provides a provider for VMware vSphere, enabling users to manage virtualized infrastructure on VMware platform. OpenStack. Terraform supports OpenStack, allowing users to define and manage resources in OpenStack based on private or public cloud. Use cases of Terraform modules. So here are some common use cases where Terraform modules shine. First is network infrastructure. So modules can be used to define networking components such as virtual private cloud, subnets, security groups, and routing configuration. So this promotes modularity and reusability across different projects and environments. Compute resources. Modules are well suited for defining compute resources like virtual machines, container, and serverless functions. Database deployment. When deploying database across different projects or environments, modules can encapsulate the configuration details. So this includes parameters such as database engine, instance size, storage settings and access control, load balancer and traffic management. So modules can be used to define load balancer, traffic management tools, and CDN control. Monitoring and logging. Models are valuable for defining, monitoring, and logging configuration. So this may include setting up alerts, log storage, and integration with monitoring tools. Security policy. The models are beneficial for encapsulating security policies and configuration. Identity and access management. Models can simplify IAM configuration by encapsulating roles, policies, and permission. Storage and content delivery. For managing storage solution and content delivery network, models can be employed. Hybrid cloud deployment. In scenarios where infrastructure spans multiple cloud providers or include on-premises components, models can be provided an unified approach to manage resources across diverse environments. And last is application deployment. Models are valuable for defining application deployment, especially in microservice architecture. Each model can encapsulate the necessary infrastructure configuration and dependencies for specific application components. So these are the use cases of the Terraform model. So applying Terraform model across environment. So development environment. So the purpose is to customize models for rapid development and testing. Example, in the development environment, use smaller instance type and enable debugging feature for faster iteration. For the staging environment, the purpose is to test integration with realistic configuration. Like for example, in staging environment, we need to adjust the configuration for larger instance type and use more realistic resource setting. And at last is the production environment. So the purpose is to emphasize high availability scaling and security. For example, in the production environment, configure models for larger instance type, auto scaling groups, and the security measures. So as you can see this example where we create a resource of AWS instance and you can see the three types of environment which is development, staging and production. So in development stage we have learned that we need to use smaller instance type for enabling debugging feature for faster iteration. So as you can see here we are using T2.micro instance type in the development while after moving forward to staging environment. So in staging environment, we need to adjust configuration for large instance type. So we require T2.small. And at last for production environment, the configure models used for large instance type for auto scaling groups and for security measures. So here we have used m4.lar. The common configuration consideration. Variable override. So the purpose is adjust configuration based on the environment. For example, use conditional statement to set variables. Example, choose instance type dynamically based on the environment. Terraform workspace. So purpose is to manage multiple environments within a single configuration. Example is to utilize Terraform workspaces to switch between development, staging, and production environment efficiently. Last is remote state management. So the purpose is to securely store and share Terraform state files. Example is to configure a backend such as AWS S3 to store Terraform state files centrally, ensuring collaboration and consistency. So now we will learn about the basic infrastructure setup using Terraform models in AWS. So our basic structure include, so as you can see, I have make a directory called as Terraform modules, a folder Terraform modules, and in that folder I have made two folders. One is of modules and one is of project. So in modules, I will be creating an EC2 instance, and in project A, I will be creating an EC2 instance, but I will refer the EC2 instance from the first model create. So now, as you can see, first I have created a folder named modules, and in that I have created one directory called as EC2. And in EC2, I have created ec2.tf file. So it is simple as I have just created an EC2 instance. You can see, and the name of the instance is my web 1, and the instance type I have given is variable, where I have declared the instance type in variable, which is t2.micro, and the AMI ID which I am going to use is Ubuntu, and here you can see the key name which is 3tier. Now I have made another folder called as projects, and in that I have made a directory called as project A, and in this project I have simply created one module, and this is the source name where you have to mention the path of the modules is present. So here you need to specify the path where the EC2 which we have created in the ec2.tf file for the reference. So this is the basic syntax of the Terraform module. And this is the provider.tf file, which you can see the profile is equal to default, which means I have specified the access key and the secret key, which is default, and the region I am currently using is AP South 1. So now, as we were discussing, so if you looked at this diagram, so we have a module here. So in this diagram, the module name is source, where you have basically added your Terraform code, as I have created and shown that we have created a resource called as the AWS instance named y web. So this will basically add your Terraform code, and from so different projects you can go ahead and call this module, and all the contents which are present within the module will be initialized. Now, one of the benefits here, let's say that you have a developer and developer wants to create an EC2 instance. So he does not really need to understand all the configuration related to EC2 instance. For example, as AMI, instance type, etc. Or it can be security group. So all he has to do, he has to call the EC2 module, which the DevOps team might have been creating. So these are the only three lines that the developer might have to use in this Terraform file, which we have created. So this is the three line. And when you go into the organization, you will see that the team, it can be DevOps team, system of team, and the team might have already created modules for various resources. And you just have to do is to call the module and create the relevant infrastructure. So now we will run this code. Then we will deploy this in our AWS console. So let us open. So now here we need to type the command terraform init. So it will install all the provider plugins and also the modules which we have created. So it will initialize the modules. So just type terraform init command. So as you can see, it is initializing the packet, initializing the module, and this is the path it is searching for the module. So as you can see, Terraform has been successfully initialized. So let's just now clear this and let us see what are the resources that we are going to create after typing the command Terraform plan. So after doing Terraform plan, it is showing that one resource is to add, 0 is to change, and 0 to destroy. So as you can see, the instance type is t2.micro. The AMI ID which we have used is of Ubuntu. Now we will just apply our configuration. Terraform apply. So just type yes. So as you can see, it is creating. So as you can see, our apply is complete and resource of EC2 instance has been added successfully. Now we will just verify this on our AWS console. So click on EC2 instance, click on instance running. So as you can see, I have not given the tag name. So click on the instance ID. So this is the public IP address of our instance created. Then as you can see, this is the AMI ID which we have given in a Terraform configuration file. Then the key pair. So the resource has been successfully created by using Terraform module. Now we will understand the challenges of the Terraform modules. So Terraform modules. Now one common need of infrastructure management is that you will be building multiple environments, as we have learned previously, that for staging environment and production and so on. So depending upon the environment that you are working with, some of the variables would differ accordingly. So for example, for staging environment, your EC2 instance might be for T2.micro. However, for production, where you will have a lot of traffic, you want your EC2 instance type will be M4.large. So similarly, depending upon the environment where you are working with, some of these values will change accordingly. So generally, whenever you make use of these models, and if you hard code a value something similar to this, so what will happen is to enable, you will not enable to change it from the destination. So for the development of T2 seems to be good enough for staging. And let's say you need T2.small for production and you need M4.large. So depending upon the environment, so the specific value related to the instance type is changing over here. Now since we have hard-coded the source model, we were not able to change it. So we have used variables.tf. So as you can see, we can use variable to create a default instance type. So it will help to manage the environment. So now we will learn for methods for using Terraform module. So there are many methods. So first method is local module resources. So the modules can be defined locally within the same Terraform configuration by specifying a local file or directory path as the source. So this example we have used in our current case. So as you can see in our project A, we have used the local source module. As you can see this. So now next is Git module resources. So you can use GitHub and you can refer to the module where you can find many modules related to many resources. So modules can be sourced from Git repository by providing Git repository URL and the path within the repository where the module is located. So this method is beneficial for reusing modules across different projects for teams and maintaining version control. Third is the Terraform registry module resources. So we can use Terraform registry if we need to create a resource. We can use Terraform registry module sources. So modules can be sourced directly from the Terraform registry, a public repository of pre-built Terraform modules. So this method simplifies module usage by eliminating the need to manage external Git repositories and allows for easy discovery of modules. Module variables. So module often expose variables that are customized when the module is used. So these variables allow users to pass specific values to the module, influencing its behavior. Module outputs. So module can be defined using output variable, and this output can be referenced in the main configuration. Module versioning. The modules can be versioned to ensure stability and consistency. Version constraints can be specified to control which version of the module is used. So this is the method for crucial managing dependencies, ensuring that changes made to modules do not unintentionally impact infrastructure. So these are the types where previously we have seen the three components of Terraform modules, which is root, child, and published. So these are the types of published modules. So now we will see in the Terraform registry. So this is the default page of the Terraform registry, and here you can browse the modules. So as you can see in the left hand corner, you can see the cloud provider name, which supports the Terraform module, which we have learned previously: AWS, Azure, Google, Notepad, or Oracle. So here you can find the Terraform module resources. So let us check for the EC2 instance. So as you can see, in third page, there is the module for EC2 instance. Click on this and you can see the source code. The path of this has been mentioned here, and the module is managed by the person name, and it is published on 31st August. So if you come down, you will find the code for the single EC2 instance. So here you can see the source path of the module. This is for the multiple EC2 instance. So you can see the provision instruction. You can also select the version according to your requirement. So to publish the modules, you need to require the GitHub for publishing your module. So anyone can publish and share modules on the Terraform registry. So published modules support versioning, automatically generating documentation, allow browsing version histories, show example and readmes and more. So the requirement description is to GitHub. The module must be on GitHub and must be a public repository. And the name of the module repository must use three-part name format, which is Terraform, the provider, and the name of the repository. And the description And the GitHub repository description is used to populate the short description of the model. As this model, you can see the description says which creates an EC2 instance and the standard module structure. So it has to be in a standard module structure, as we have seen previously of main variables and output.tf file. And the version should be optionally be prefixed with the version example for version 1.0.4 and 0.9.2. So this was the high level overview how we can create a module using Terraform registry. Now we will conclude for today. So the Terraform modules are a powerful tool for managing your infrastructure as code. So they provide reusability, consistency, and organization, helping to streamline infrastructure deployment and management. However, it is important to strike a balance between abstraction provided by modules and unique needs of your infrastructure. A careful and considered use of Terraform modules is required to successfully improve your workflow. Thank you for watching, and if you enjoyed this video, don't forget to like, share and subscribe and hit the bell icon for more content. Feel free to leave your thoughts or suggestions in the comments below. See you in the next video. And for reference, you can visit the official website of Terraform registry as I have shown you. And if you have any query, please contact us. Thank you.